start. There we go.
Okay, can I start first?
Sure.
Okay, cool. Morning, everyone. Hope everyone is doing well on this happy iTOOsday. So today's iTOOsday is going to be centered around what's been going on in the construction industry over the last year. And we know that the sector has taken the hardest knock recently, with the halting of all works during hard lockdown, followed by the massive infrastructure damage caused by social unrest and climatic catastrophes. So long before these events even happening in the construction industry, the industry struggled through various pressure points, such as growing economic pressures, low markups, skill shortages, and supply chain shortages. And these pre-existing pitfalls combined with inflationary increases paint a bit of a dim picture. However, it's not all doom and gloom. The sun is shining today, so there's still a desperate need for infrastructure development in South Africa, and this means that ultimately there will be positive development in that industry. Right, Fiso and Martin?
Yes, definitely. From an underwriting point of view.
I won't comment.
So South African firms are also exploring the use of new technological advances in design, construct, and project management process, which will ultimately reduce errors, we hope. So for instance, Fiso and I were talking yesterday about BIM, which is short for Business Information Modeling, which is the 3D model-based process that allows professionals on a project to collaborate on a cloud-based platform, and they eventually kind of build a 3D model of the entire project. So that will maybe reduce some errors or human errors, we don't like to say. But ultimately, I think we need to know that robots are taking over. We're not even real people right now, we are robots. So, okay, so today we are joined by our resident construction expert, Mr. Martin Vass. He's going to bring us into the picture on some of the recent claims he's worked on, and as well as Fiso, who's going to help us on the underwriting side. I just want to, for those of you who haven't worked with Martin as yet, don't think that we've ever read his bio, which is very interesting. Let me tell you a bit about Martin. So after graduating in the UK, Martin joined LTA in South Africa, initially as the site engineer, then site agent on motorways around Martin, we say highways around Johannesburg. Martin then left South Africa to take up a position with Fletcher Construction in New Zealand, spending time in Australia. Some years later, Martin rejoined LTA in South Africa again as a site agent and project manager on the motorways around Johannesburg. Following a number of years in the construction industry, Martin joined Neil Savage and Associates as a loss adjuster, specializing in CAR, PL, and PI matters, our favorite. So Martin now works with Richard Baker at Specialist Adjusters, still involved in CAR, PL, and PI claims. And Martin is also the past president of the Institute of Loss Adjusters and lectures regularly to contractors, consultants, insurers, favorite insurer is iTOO, and brokers on failures in the construction industry. So he's a regular traveler to claims throughout Africa and the Middle East. So we're excited today, Martin, to see some of the stuff that you've been working on.
Thank you, Tommy. That's very kind. A very nice introduction. Thank you very much. I couldn't have written better myself. So what I'm going to do now, good morning to you, everyone. What I'm going to do now is just go through some of the recent claims which have occurred around the country and throughout Africa. And I'm going to bring you some of the older claims. And what Comedy correctly said, we specialize really in PI and works claims. So I'm going to start off on the first one with, it's a combination of liability and works. And that is all the problems we had down in last year with the floods in Natal. So I'm really concentrating on one place, which I'm Sloty. And I'm going to bring up the first slide now, and I hope everyone can see it when I bring it up. On the bottom right corner, obviously is the sea, which you'll see there now, and that is Sloty there, which is that ribbon of development along the seashore. And what has happened now, if you see behind that, this very large area, which is really in the middle of the slide, that is a new development which is going on in Sloty, which, as you see from the size of it, it literally dwarfs the existing town. So this new development on the left there is a mixed-use development. It's townhouses, it's apartments, it's And if you see on the left-hand side there, on that new development, that's a very large shopping center they built there. Now, what happened here is with the heavy flooding, which occurred last year, all the water from that new development discharged itself through Sloty. Now, if you can look at it, you can see two very large scours through Sloty. I wish I had a pointer, but I don't. There's two very large scours, and I'm going to show you what's happened when that water discharged from the new development. Any of the legal minds out there, they can have a chip in, because what's happening now is that the Sloty residents are starting a class action against the developers of this new development. I'm not sure how that's going to fly, and whether the insurers will join that class action, and when in fact they will be successful in a class action. I know you're allowed to discharge water from your property, and therefore the new developers could discharge water, but I think it's the controller that water has been a problem. The other problem we have with these small Sloty, Schlanger is a bit better now, but a lot of the old kind of coastal towns had never in fact upgraded their services. They hadn't put in stormwater, their sewage systems are very basic. So what's happened here, there is no stormwater system in the existing Sloty town. So when this water came down from the development above, it just swept through Sloty. And I'm going to now go through some of the photographs where that water came through Sloty. So here is one of the large kind of dongas which formed itself from the water coming from above. And you can see there quite clearly that apartment building, some of those were permanent residents, some were holiday residents. The end of that building was completely taken away. And in fact, we had to demolish a large portion of that block of apartments. And we've in fact put in almost like a park in that large slot. We also took the opportunity of putting large stormwater pipes because nature had cut us a trench there. So we put the pipes in the bottom of that gorge before we backfilled it and grassed it. And I think I've got some photographs coming up showing what the final kind of configuration looked like. But it's very sad. Obviously, where the insurers were involved was paying out for these various apartments which disappeared. And they may or may not form part of the class action against the developers. And anyone can step in anytime. Please, if you're going to ask a question, ask them to go along, don't wait to the end. So there you can see what happened. You see the amount of water that came down, and which brought a huge amount of silt. That building on the left in the foreground, on the right in the foreground, the entire basement and the parking underground got completely filled with silt. And in fact, it's taken many, many months to clear out those apartments. And obviously the demolition work above. So go a bit forward, you can see quite clearly how it's collapsed. And the existing structure on the left-hand side, I think we went back 2 or even 3 apartments to get back to something that was stable. Behind that, right at the back of that kind of donga you see there are the parking garages. Again, we have problems with lots of vehicles being taken down through here as well. That has all changed now. There's a very large inlet structure right above, behind this development. There's a large inlet structure and the pipes going down now, taking the stormwater straight out into the sea. And I think I've got some photographs showing those pipes.
Martin, were those buildings, sorry to interrupt, were those buildings evacuated before that happened?
Some of these ones on the right-hand side there that were developed were in fact holiday homes. They weren't evacuated, but I can assure you no one was actually killed in these apartments. But they weren't evacuated because, I mean, this thing happened very suddenly. This material here is sand. It's the old sand dunes going back many, many hundreds of thousands of years. And it's very susceptible to water. So it just washes it away. But no one was actually killed. They were evacuated afterwards, I can assure you. And this is what the kind of the road looked like through Sloty. And on the right-hand side, now I'll show you another picture. This is where people used to walk in the evenings. And as you can see now, it's an absolute disaster. This is one of the apartments where the water came in the back of the building and came out through the front or through the kind of patio area. It's quite a nice mud waterfall that's going on there, and I think I have one taken actually inside, and I'll show you. Okay, so this is the front. You can again see the water coming through those. The one you can see the water coming over now with the mud. The one next door to it, where you see the staining on the wall, had exactly the same thing. The water came straight through the apartment and went out onto the front. Here you can see inside the building. So I think there's some water damage to the carpets there. So you can see what happens inside these buildings. Quite dramatic. In fact, this picture actually appeared on overseas newspapers or overseas. I think the BBC showed this particular picture. Absolutely devastating what happened to these apartments. This is a house that was again on the second donga, the two dongas, and I go right back to the original picture, showed the two dongas. This is a house on piles. Now you see the piles, which are the kind of the brown concrete structure under the house. Those piles are what you call friction piles. So they depend on the friction between the ground and the pile. You have two types of pile. One pile goes down onto solid rock, and the house will then sit on the rock. Or you have what you call a friction pile, which depends on the friction of the sand against the concrete. Now, with the sand being washed away, there was no further friction. That house, in fact, was demolished. The house was taken away. We couldn't save the house. I was down there just a few weeks ago, and I see the same owner has rebuilt on the same plot. So I just hope he's put piles a little bit longer or something different, because he's actually rebuilt that house. House was totally demolished. If you look along this was taken a bit higher up, looking along the foreshore there. And I think I have one of the, again, you can see there. And this was the nice walkway along the front. In the evenings, people used to wander along there. I was there, as I say, just a few weeks ago. That road is being rebuilt. Most of this walkway has also been rebuilt. They've had to push it back out again, replace the sand, put what you call Loffelstein, which is like a wall to protect the sand. That has all been replaced when I was there just a few weeks ago. So the place is looking a lot better. The damage is still very visible on lots of the structures there. So it really was absolutely devastating for Amsterdam, absolutely devastating. This was another set of apartments that also got demolished in the second one. And if you look on the right-hand side, we had that problem with all the motor cars. That one is just hanging by a thread. Look, it's going to fall over any moment. What we did on one particular part, we had two Range Rovers in the garages, and we used a crane and just picked them out. We took the roof off and just picked them out. So this structure again was totally demolished. None of this apartment building was saved. We took it all away and we replaced it now with grass. If I can see the grass coming up, maybe, yeah. So that's what we did. We took that away and going back. So that was taken away. That was all cleaned out. This big donga in the front was all filled in. And what happened then, we put the pipes in the slot and we've then grassed that area and made it into like a semi-park. And if I think I've got the pipes, yeah. So these are the pipes going back. The pipes run underneath. There's a very large inlet structure sitting on top of the hill there now. The water runs down through these three pipes and discharges straight out to the sea. I'm not that keen on the design here. I think those pipes should have been a bit lower because I think they'll just take the beach away during a heavy flood. But that was a council design, and we weren't involved in that design. So that's hopefully going forward will now stop another donga being formed if heavy rain occurs again, and also with the discharge from the development above. So it's going to be quite interesting how we go forward as far as the court case is concerned, and whether in fact the insurers will join in the class action from the people who are uninsured, which are quite a number of people. So they're starting this action at the moment. Okay, this one is now going forward one. Yeah, this one now is this is I'm bringing up a little bit. Are there any brokers listening, or is it just purely insurers?
No,
Brokers.
Are the brokers involved as well?
Yes.
Okay, so let me explain what happened here. This was a hydroelectric scheme up in Ghana, and it was a dam, and you can see the pipes that were formed part of the dam got washed away. And I'll take one. That was the flood, and this is part of the structure on the left-hand side here. where you see this massive water and rocks in front of you, that was where they were building the actual power station in the river. Now, the problem here came about is that, and I'll go back one, the problem here is that like most of these African developments, there is a local insurer. So what happened here, the local insurer takes, I think he took 5%, and the remaining 95% was to be reinsured. So then we had the flood, we then got involved, we were appointed on the flood, and we then reported to the main insurer, who in turn advised the broker to submit their reports to the reinsurers. It was then found out that this was not reinsured. The broker, in fact, did not reinsure the project. So the lead insurer would pay out what it was, 5%, but then there was no reinsurance after that. And in fact, this was a PI claim against the brokers. So it's just a point, if you are insuring up in the African countries, to make sure the reinsurance is in place. What happened here then is they had a second flood, and it took it away a second time. And what happened here, when we did a report on the first flood, we pointed out that the contractor had not adhered to the 1 in 10-year return period. His temporary works were under-designed. When the broker reinsured the second time, he did not advise the insurers of the problems on the first one. And in fact, when the second claim occurred, they declined the claim. So it's a combination of errors here. So the broker was faced, in fact, with 2 PI claims for this flood damage. Any comments? Please come in with comments if you want any instead. That's the remedial work going on. That is some of the temporary works being put back. And those are some of the temporary pipes on the left there that were washed away. There's no problem. I'm coming up later on as far as the power stations are concerned. In this country, as you know, most of the electricity, so I should say that, if we have electricity, most of it comes from Eskom, and most of it is coal-fired. So we have coal-fired power stations here. There's a little bit, there's nuclear from Kuberg, and there's a little bit of renewables. But at the moment, the majority of our power comes from coal. And what happens with the coal here, we produce a lot of ash. And what you see in front of you are the ash dumps. And this is where we have to store the ash and prevent it being leached into the underground water. So what you do is you build these very large dams you see in front of you. And it's very hard to get the size, but if you look down the bottom, you can see trucks to give you some idea the size of an ash dump. So what you have to do with this ash dump, you have to line it with plastic and seal it to prevent rainwater leaching out the harmful metals into the ground. And we have a lot of problems with these dams that the plastic liner, because it's such a large area, gets ripped up by the wind. They try to hold it down. They've got bags to try to prevent it curling and blowing away. But we do have a lot of claims here where this plastic liner is damaged. I think the next one will show. Again, you see some idea of the sizes. Again, on the left is a ash dam which is being filled. That ash dam on the left is no longer in service. And this is the new ash dam going up in front of you here. And that is some of the lining which has been damaged. It's hard to see, but if you see the left-hand side, you can see the lining is all wrinkled there. And that is where the wind has moved the liner. And a wrinkled liner is not acceptable. It all has to be cut out. So this liner was cut out, just that wrinkled area there. And on the top right-hand corner, you can see some more wrinkled plastic. The replacement cost that was about 8 million. So that gives you some idea of the kind of area of plastic involved.
Martin, would then the responsibility with the engineer, if there's any damage or mistakes, or with the mining company?
Never with the mining company. The mining company, when they give out the contract, put the responsibility on the contractor, and it is then a disagreement between the contractor and the consultant, which we've had actually on this claim. What happened on this claim, the contractor said, we did enough security, we put enough bags down. The consulting engineer says, no, you didn't. We told you over and over again, you didn't put enough bags, and therefore we don't believe you have a claim. it went back and forth for some time, I can assure you. And what has happened now, insurers have agreed to a compromise offer. So that's what we've made. We've made a compromise offer, which at this moment has not been accepted by the contractor. But yes, it's never the client. Normally, it's not the client, because the client takes those responsibilities and gives it over to the contractor or the consulting engineer. They don't hold it themselves normally.
Cool. Thank you.
Okay. This is up in Lusaka. And what happened in Lusaka? Lusaka is subject to flooding, stormwater flooding. So what the Americans decided to do was to finance a canal system in Lusaka to drain the water away and feed it down into the rivers. That's what the contract. And what the Americans said, we'll give you this money on the understanding it's a lump sum. We give you that money and it's for a 2-year period. You've got to spend the money in the 2 years and you've got to finish the job. So they let this job out to the consulting engineers and also to the contractor, and it was to build these concrete canals. Now you can see what's happened. After they completed the job, a couple of problems here. Firstly, they fenced it all the way along each side of the canal. Now the fencing, obviously, I'm saying obviously that's not the right word, but the fencing was stolen. It was sitting there and people just literally cut it away. And that then became a problem as far as the children are concerned. And if you look at the top left corner, there's children playing in those canals. And it's the children, the whole idea was to keep the children out of the canals. What happened then is after they completed, the canal started to fail. And you see that in these pictures, the bottom 3 pictures, you see the canal walls have actually fallen inwards. And this is a design problem. They didn't design the material behind the wall to drain sufficiently. So what happened here, the water didn't drain from the back of the wall. So it built up behind the wall and the water pushed the walls over. And it was a design error. The problem now comes is that the Americans will no longer finance it. The Americans said, we gave you a lump sum, we gave you a period, it's over. We're walking away. So at the moment, we're sitting with this problem that the government is trying to hold both the contractor and the consulting engineer liable for this. They have a problem themselves. They can't leave it because of the children. I mean, you have children in this, and you have a flash flood, you'll lose children. So the government has gone ahead with the remedial work and instituting action. We're defending the consulting engineer, so they're holding consulting engineer and the contractor liable. So I think I have another one here. You can clearly see bottom left corner. This is typically what's happened, is the whole wall has fallen over, and then you see there's a child just walking along here. I mean, that child can, even if he doesn't play in the water, can fall, and even that can either hurt him or even kill the child. So it's a real problem here in Lusaka at the moment, as far as the children are concerned. Whether in hindsight we should have made closed boxes so no children get into them, I'm not sure. But it is a major problem we have at the moment, and that is an ongoing claim. And it's a very large claim indeed, because we've got to go back and replace all these canals. It's a big job.
Martin, you said that the material behind wasn't designed correctly. Is that technical, or were there specific?
I'm going to bring up a design which you should do. What they did here is they put what you call a weep hole. Those are holes, and I don't think we can see them on this. No, we can't see it here. But at the bottom of these walls are what you call a weep hole, which is holes through the concrete. And then what you put behind the wall is stone material, which drains easily. And the idea is the water comes against the wall, runs down through this stony material and goes out through the weep holes into the canal. That is the idea. But what happened here is they didn't protect the stone. They should put a material called bitumen, which is like a shade cloth material that you protect the stone to prevent ground going into it. So keep it as stone and free draining. They didn't do that. So what happened after a very short period of time, the soft material went into the stone, and the stone no longer worked as a drainage material. So then the pressure built up from the rain. Now going forward, and this is how you normally do it. So when you're going forward, how you normally do it, this is before the concrete now. So you put these vertical drains in there, which are called wick drains, and the pipes sitting out the bottom, those white pipes, then go through the concrete. I'll show you another one. So those are called wick drains, and this is what happens. So then you put the drains in, it then comes out through the wall at the bottom, and then you cast the wall. That is typically how you do it. They didn't do that at all. They put in this material, this stony material with drains, and the stony material just got itself bunged up with soft material and no longer worked. And with that, the pressure of the water literally pushed those walls over.
And did they do that because it was less expensive, or was it just a design failure?
It was a design failure. And it's the first question we asked when we had our first discussion with them. The bidum, we looked at the drawings and couldn't see the bidum. We said to them, "Where's the bidum?" And they said it was never put in. So that without the bidum in, the stone material doesn't work. You have to protect the stone material to stop soft material going into it and bunging it up. So they didn't do that. So they would have been better off putting something like this. So the water would drain behind the wall and come out through the holes. That's what they should have done. So it's a design error. But it's expensive. You're going back now, because now it's actually worse, because now you go back, you're not building anymore. First you've got to do is demolish all this concrete. So you've got to demolish all this concrete, clean the whole place out, take all what's left of the fencing away, and start again. So in fact, you've got a greatly increased cost than the original project.
Yes, and the clearing away is usually more expensive than the rebuild.
Quite right. You've got to knock all this concrete out. Okay. You've got to protect it. And going forward, I'm not sure what you do about the children, because if you put all the fencing back up again, you see what happens to the fencing. So how are you going to stop the children going into the canals? It is a problem, a real problem. We have it on another job in the Free State, and I don't know why I got photographs of it, where they left the trenches open, they filled up with water, and the children fell into these trenches. A big problem. And I think I got a couple of those photographs. So this thing of temporary design, safety, etc., is a major concern on construction. If you've got a building on a construction site, you can keep everyone out of it. But when you're building canals in a residential area, it's very difficult. Very difficult. And in the bottom right-hand corner, you see the houses are right next to right next door to the canals. Children are there all the time. Big problem.
So somebody asked a question, Martin, can they not close the canals up from the top?
They could, and they could put a cover on. Again, they've got to rebuild them. So that they've got to demolish all that, not to rebuild it. Yes, they could put a cover over the top. I think that is a very good idea, to cover it up, and then put manholes and make sure the manholes are secure so no children get into them. I think that should be done. I think that's one the Lusaka government, hopefully that's what they will do. Just put a cover on top of them. Yes, just put a concrete cover.
Thanks.
Again, it's cost, a huge cost.
Yeah. And then Kyle asked, did the contractor not pick up the issue within the maintenance period?
The issue was a design. If it had been picked up in the maintenance period, it was not a contractor's problem, it was a design problem. So if it had been picked up in the maintenance period, you would have been left with the same situation. You can't retrofit. You can't go back and do anything about it. The mistake is in the design. So if it had been a contractor's problem in the maintenance period, yes. And then what you do then is you don't issue a final completion certificate. What you do then, you'll have the practical completion certificate, and then you'll have normally a 12-month maintenance period. If in fact you have something like this, which is a contractor's fault, you then don't issue a final completion certificate until they've sorted out the problem. Then you're not bound by the 12 months. Then you could go on until they complete the remedial work. And we have that on many projects where there is something in that 12-month maintenance period, and then the final completion certificate period is extended. Anyone else?
Thanks, Martin. No, nothing else on this one.
Okay, this is where we're spending a lot of time at the moment, and this is on our power stations. And I can talk about this one now because it's been in the press quite extensively, and which is our friends at Kusile Madubi. Now, on a normal power station, you have cooling towers. Now, a cooling tower allows you to take the water and cool it before taking the water back into the power station. but there is insufficient water in Kusili and Medupi. So what they've done, they put dry radiators in. So if you see that structure in front of you here, that on these columns, those are very large radiators which you get in a motor car, and they have fans underneath, and they cool the water. They pump the water through these radiators and they cool it. So that is the structure in front. Behind that, at the moment, we have 5 boilers. Those are the 5 silver buildings, and the 6th boiler is under construction on the left-hand side there between the 2 chimneys. Then you have the chimneys, which you see in the background. The chimneys are made of concrete, which we call a windshield. And inside that windshield are the flues. So if you look on the top where the smoke is coming out, you'll see 3 steel flues sticking out the top. So what happens, they are supported by the concrete windshield. So there's no flue goes up the concrete, they go up inside those steel flues. And that I'll explain to you just now when I bring up what has happened at the Kusili power station. So what they've had at Kusili, which is this one here, on all the other power stations in South Africa, the sulfur which is produced during the burning of the coal is just taken out through the chimney. It blows out into the air. The problem with that is that when you have rain, you turn sulfur into sulfuric acid. So what on the 2 new stations, they insisted to have what you call a gas desulfurization plant. And the whole idea of that is to take the flue gas and take out the sulfur before you put it out into the atmosphere. And this is where the problem has arisen at Kusili. So what happened at Kusili, to do the desulfurization, first you've got to take the ash out of the flue gas. So you must take the ash out. And they have a thing called electric precipitator. What it is, it's vertical panels of steel panels, which are electrified, and the ash sticks to them. So that takes the ash out. Then it goes through a screen of water, and then they add lime. And that, in fact, takes the sulfur out. That is how the system works. What they were doing here at Kusili, they were not maintaining it correctly, and they were not taking the ash out of the flue gas. So what they were doing, they were taking a lot of the flue ash, and they were mixing it with water and mixing it with lime. And that really is low strength concrete. So they're actually producing concrete. So what happened then, it built up. This is one of the flue tubes that go. So on the right-hand side here, you have the concrete windshield. Going into the windshield is 3 flues, and I think I have it here. Yeah, those are the 3 flues. So they're coming in to the windshield. This is the windshield. There's the stairs on the right-hand side to walk up the windshield. So these 3 flues coming in here are from 3 separate turbines and 3 separate boilers. So they go here and then go up and they discharge into atmosphere at the top. The right-hand one, the top, oh, sorry, go back. The top left-hand one there is the one which has failed. So what's happened there is the material has built up inside this duct. And this duct is 9 meters diameter. To give some, 9 meters is a very large duct. And that duct filled up about 2 meters of this ash and lime and water. And it built up about 2 meters and got to about 90 tons of material, which in fact resulted in that top left flue dropping about 2 meters. So that flue is out of action, therefore the turbine is out of action. So immediately that comes off the grid. Because of the potential of that top left one collapsing, they took the other 2 also offline. So we really went from kind of level 2 to level 4 load shedding because we lost these 3 turbines. So that is what. So what the option now is to take this away, clean this out, take this away, and unit number 6. So if you remember, that was still under construction. So that one, that left-hand one is still under construction. We have the flue tubing for that unit. So we're going to take unit 6 and take out that top left-hand, which is unit 1, and replace it with the ducting from unit 6. But it's going to take us about a year to do that. On top of that, Eskom have gone to the government and said, if we have to replace the desulfurization plant and get it working again, we can't get Kusile up for 2 years. So they've approached the government have given dispensation not to reinstate the desulfurization plant as a temporary measure. So in about a year's time, it'll be working again, but it'll be blowing the sulfur out through the top of it. And I haven't seen the program yet to say when the desulfurization plant will come back into use. I don't know that yet. So that is the problem we have at Kusile. And that is why we have load shedding up to level 4, because those 3 are out of action. Any comment? Good, very good. Okay, either I make sense or I don't make sense.
You did make sense. We have a question, Martin,
Please.
to ask, is it the same at Medupi?
Yes, it's the same design at Medupi, exactly the same. It's also got the desulfurization plant, but at Medupi, only 1 unit is working at the moment. The other 2 units are not working yet. So hopefully they do their homework at Medupi and clean those ducts and don't allow them to collapse. Look, we know what happens now, but which is a little bit annoying. They were told before the collapse that this is a possibility.
Yeah. So what's the consequences of not having the desulfurization plant? Are people just going to get rained on with acid rain? Yeah,
you're blowing the sulfur out through the top. So the sulfur then drifts downwind. It goes through Mpumalanga, goes across to Kruger Park, and if you get any rain, then you get acid rain, because water mixing with sulfur gives you sulfuric acid. Yeah, you get acid rain. But just bear in mind, all the other power stations here are blowing out the sulfur anyway. They don't have a desulfurization plant on any of the other power stations.
Okay.
So they've been blowing out sulfur for years and years and years. Anyone else? Okay.
We did have another question from Taba, where he was asking if there is a stage where the designs get submitted first before the project starts in construction.
Yes, absolutely. The design is done before any construction starts. The design is finished and the drawings are issued. On a very large project, let's go back. On a small project, let's say a house or something like a small project, all the drawings are complete and given to the contractor and he builds. There are changes made. You know, someone will come along and say, oh no, you know, I want something different in the kitchen or something, and that would change. On a large project like this, the design is done very much in advance, okay? But the drawings are only issued as the work, because there are thousands and thousands of drawings. So the drawings are produced as the contract goes forward. And this contract is 6, 8, or even 10 years long. So the drawings are changed, modified, design is changed, but the basic design is done before the contract is awarded. Because you have to. You've got to order the big parts. You've got to order the turbines. You've got to order the boiler. You've got to organize the big items and purchase those. And therefore you need to design before you start construction. But the drawings are changed. Design changes as the work progresses. Anyone else? Okay.
Sorry, then there was, why was the error at Kusile not rectified before failure?
Yes, and that is a question you have to ask of Eskom, because they were aware that this was happening, and what they should have done is taken that unit offline, stop any hot flue gas going through it, and clean out that material. Go in there, clean it out before this failure occurred. Absolutely, there's no doubt about it. That should have been done, and it wasn't done.
Okay, and then the last one on this is, what is the danger of sulfuric rain?
It's sulfuric acid or sulfur rain. Sulfuric acid is harmful not only to us, but it's harmful to crops and harmful to animals. It's really not good to have sulfuric acid. It's very harmful material. It's not good to breathe. Even sulfur is not good to breathe. And certainly sulfuric acid on the environment is bad. Acid rain is bad. It's bad for the environment. It's bad for rivers. It's bad for wildlife. It's just not good to have. And that's why they put these desulfurization plants in these new power stations. And there's no discussion about going back to the old ones and retrofitting. That is not being discussed at the moment, because Eskom said to go back and retrofit the old ones will cost something in the region of 400 billion rand. And no one's coming up with the money. As you know, I think the World Bank is putting forward various proposals so we come off coal and go more renewables. But I haven't seen much happening on that yet. It sounds a bit doom and gloom, doesn't it? But anyway.
Very scary.
It is a bit scary. It doesn't sound scary until you put it up on the screen here. Then it looks scary. All right. This was down in Durban, again with the floods. And amongst all those bits and pieces, sitting just above the middle of the screen is what we call a dry dock. So it's hard to see. You see the ship's anchored on the right-hand side up there, and then there's a ship in the dry dock. I don't know where you can see it. There's two dry docks with a center gate. Can you see that, or am I talking to myself? Yeah. Can you see that dry dock? No.
Whereabout is the dry dock, Martin?
Sorry?
Whereabout is the dry dock?
I can't. Can you see? Can I move that? Can you see that?
Yes,
No.
you're moving it. You're showing it to us. Yeah.
Okay. Oh, I didn't know I could move. Why not see if I can move? Okay. So there's the dry dock, and there's a ship in the dry dock. And then next to it is a second dry dock there. So what they would normally do is they would open both these gates, that gate and that gate. They would flood the dry dock, both of them. They would then take one ship in there, close that dry dock, and then take the second ship in there and close that. Then sitting down the bottom here is a pump station. You can see that blue structure there. That is a pump station. So what happens once the ship is in place, they then pump the water out of these two dry docks, and then they can repair the ship. Running along this road here is an existing canal, which is closed over in most areas. You can't see it. It's open here and there, but closed mostly. What happened during those extensive floods we had? The water came from this canal, came across this road, flooded the dry dock, and flooded that pump station. And what was happening at the pump station at the time, this dry dock is about 90 years old. It was way back before the war. And what they were doing here was replacing all the pumps. So if I can go down one, that's the dry dock. So typically you fill that dry dock with water, you open the gates, fill it with water, the ship then comes in. As you take the water out, the ship settles on those timber bearers there, so you can clean it. Then this is the pump house. And the bottom of the pump house is the bottom of that dry dock. So it goes down to the same depth as that dry dock. That is the canal, which overtopped. It came from that canal right across and flooded dry dock and flooded the pump station. And that's what happened to the pump station. It got filled up. Now, the problem here is they just installed all the new pumps. Just installed them. So there's some of the new pumps. This is after some of the water is taken out. Those are the new pumps that have just been installed and totally flooded with the floods. They'd imported these from Germany, and they were all destroyed. A lot of money went down the tubes here. You can see the damage from the flooding. Very extensive damage. So all these new pumps we managed to save the casings, but the motors and everything gone. So we had to replace all that. And that was, again, that was a flooding last year in the town. Okay, this would get a lot of problems. This is a tower crane. This is a tower crane building a structure here. And the tower crane was on a bogie. You can see the bottom right-hand side. It was on a track. And what happened here is they didn't fasten the tower crane sufficiently to the track. So when they had a high wind, the wind blew the tower crane and the little bogie along the track until it hit the stops at the end, and the crane fell over and went down through the structure, which you can see there. It's broken the seating of the stadium, and obviously demolished taken part of the roof with it, and obviously demolished the tower crane. So again, that's a safety aspect. You've got to lock these cranes, these tower cranes on these bogies when you're not in use. You lock them down so they can't move. This one was not locked down. This is a parkade, and I've got a couple of pictures of the parkade. This is a parkade at the station. And what happened here is they designed it with what we call post-tensioning. Again, it was a design defect. They put insufficient, you see the cracks starting to appear. You see the cracks starting to appear inside. You see the cracks appearing all over this. They put insufficient steel in the design. We tried to save it, but we put carbon fiber strips under that slab. Carbon fiber is the type of material that you adhere to the bottom of a concrete slab to supplement the amount of reinforcing steel. They put in the carbon fiber. We didn't want to, and the contractor wanted to do it. He went ahead and did it. He spent 18 million rand on carbon fiber. It didn't work. So what happened? This parkade we demolished. We took it all away and we rebuilt the entire parkade. This was down in Mozambique. And what happened here in Mozambique is they built this new structure, and they're building a new structure on the right-hand side here. And as you see, it's well above the level of this, what, 3 or 4 story building on the left here. But what happened with the building here on the right is they under-designed the foundations. So what happened, this building on the right started to settle, started to slide down into the ground. So what it then did, it started to drag down the building on the left. And you see here, you see the column here on the right on the existing building, how it's being dragged down by the new building on the right. So here we had to come, we didn't want to demolish that entire building. So we came in here and we did grouting and underpinning on this existing new building. We also had to come back and we had to repair this old building here. We had to do some fairly extensive work on this old building. It's a lateral support. It's a strict liability claim. There is no argument. If you've damaged someone else's building by your structure on the right, you have no argument. You've either got to repair it or come to some agreement. So we went in there and we repaired this old building and we underpinned the new building to make it more stable.
Why is it built so close together, Martin? Shouldn't it be like a space here?
Touching each other.
Yeah. Or there is a space that I just can't see.
It's literally every square. I can't believe it. And it was one of the first questions. Why don't you just leave a small, even a passageway between the two buildings? And it wouldn't have, I think still it would have dragged down because it didn't drag the building, it dragged the foundations down. So I still think the building would have been affected, but I don't think quite as dramatically as this, where they literally built it against it. And it's very unusual. We don't have in South Africa, you actually build one against the other. We don't have that. We normally have a small gap. This was one, again, a design defect on the slabs. This is the motor dealership up in Pretoria. And what happened here, the slab fell down, as you see. And again, it's a design problem. It's insufficient reinforcing. And this whole slab fell down. So we then had to come back. We had to demolish that slab. We then did a design check on the rest, on the rest of the building and found the other slabs were the same. So we had to come back in here and we had to retrofit this building. We had to put in additional beams, additional reinforcing on those floors to hold up the existing floors before we repaired the building. That was a design error that was under the PR policy.
Martin, if the design is always checked and verified, don't they ever pick up these errors before you guys have to come in and fix the error? Because if the engineer has designed it incorrectly, surely they can pick that up in design stage.
That is a great question, and I wish you would come and talk to us as part of the Institute of Engineers. It's a great question, and Kristen, that's a seminar on its own. It really is. What we have at the moment in the, and it's going back a long time, it's not new, but what we have a problem at the moment is mentoring. And what's happening now is that there's insufficient mentoring of the new engineers coming through. What's happening is that a lot of the old engineers have retired. They've headed off to Nice or Pletta, where the hell they go. So, and the youngsters are not left with sufficient mentoring. And mentoring in engineering is just as important as getting your degree. You know, you can get a degree, which means you can do a design, but you need to be mentored to tell you where the problems are in that design. So what often happens is that a young engineer, I'm not, because we have a lot of other engineers also making mistakes. The young engineer, whatever the computer tells him, that is right. So it doesn't matter if you put junk in, what the answer is right. So junk in is junk out, and that's what we're finding a lot of. The computer tells you got to do this, and that's how the design is done. You're quite right. These errors should be picked up at design stage. There's no doubt about it, no doubt. Fortunately, they're not, because I wouldn't have a job. But yes, they should certainly be picked up at design stage. And a lot of companies, a lot of the bigger companies here, and I think of people like Arab and those kind of things, they have an in-house peer review program. So what happens there is once the design is done, they then give a peer review within the company itself. And that's done on the larger companies. But a lot of smaller companies don't have that manpower to do a peer review design.
Yeah.
But it's a good question, and it's a question which is being floated around for a long time now. Yes, you should. You should pick it up at design stage. You shouldn't allow the design to go out with errors in it. You're right.
Yeah. Thank you.
But also in these type of claims, to me, it seems like it's such a fine balance, because you can either under-design or you can put too much of steel or propping in and then over-design, and then you get sued for that.
Yeah.
Dominic, you're so right. And we have a lot of claims on at the moment, mainly in structural steel buildings, where you have, like, let's say, a warehouse or a factory, and they are suing our clients for over-design. They are saying, you know, you could have made this a lot cheaper and saved us a few million rand. So they really work on a very tight balance between sufficient and not too much. It's a very fine balance. It really is. And we have a warehouse at the moment which they're suing us for a lot of money because they said we've over-designed the trusses and the beams. It's difficult, very difficult. The engineer is working, and the client is saying, I've only got a budget for so much. The engineer should say, I don't care what your budget is. This is the right design. It's a balancing act. It's very difficult. This is conveyor again. This is a design problem. This is in Ghana again. And this was again an under design. You must allow for an overload on the conveyors, and that's what they did. They overloaded these conveyors, so the conveyors had too much material on and caused the collapse of the conveyor structure. Okay, what do you allow for? Do you allow for the guy to overload twice, or 200%? What do you allow for? Anyway, here they said it's a design error. You didn't allow enough safety factors. This claim was met. But there was quite an argument to say you've overloaded your conveyors. It's quite an argument. It really is. And this is not the first one. We have one like this in South Africa, very similar to this, where we said you've overloaded. In fact, the one in South Africa, we repudiated, and the repudiation was accepted. The client did pay. But this one in Ghana, we've actually paid for. And this was a harbour. In fact, it was Durban Harbour, when they decided to widen the harbour. And what happened here is they put a tunnel under, they lengthened the tunnel. We had a fire in the tunnel. That was a separate claim. So here what they're doing, they're widening the entrance to the harbour, and you see the dredger, which is the green thing in front of you. That is from overseas, and that dredger then takes away the sand, which allows them then to widen the harbour entrance. As they're widening it, they've got to protect the sand banks. And if you look at the bottom part of the picture, you see those are white rocks or white concrete structure, and that is protecting the sand from slipping down back into the harbour. What they did wrong here is, because that dredger there cost R1 million a day, they didn't want it standing idle. So what they did, they kept going, taking the sand away, widening it without putting sufficient rock and concrete to protect the walls. So they only got so far, and the whole lot slipped down back into the harbour. So we had to take all that additional material out. Cost an absolute fortune. Because as I say, that thing was costing R1 million a day. It stood for about a month while the decision was made, and then we used it to take the material out. So that was a very large claim. You see the bottom side here. You can see the white on the top of the picture, and the crane placing those concrete and placing the rocks. And they just weren't going fast enough doing that work, or going too fast with the dredger. So there's a combination of the two. This was on the highway, the concrete highway. The concrete highway was always concrete. Now, as you know, it's tar, it's premix. What happened here? They decided to overlay. That's put a layer of premix over the concrete. And what happened there? It didn't adhere to the concrete. It came off. It slid off. It was an absolute disaster. So what we had to do, come back, and we had to take off that whole surface again and replace it. And what we did the second time is they scabbled, they roughened the concrete surface. They applied a tack coat or a tar, and they put the material back on another surface on top of it again. Again, this was a big argument between the consulting engineers and the contractors. As far as I'm aware, and I'm just thinking back a bit, we didn't pay anything out on this claim. It was a matter that sorted out with the government or with Sanrail. Sanrail and the contractor consultant came to an agreement. The insurers weren't involved in the final payment on this thing. But here's a typical problem. You come along, you want to resurface, but someone hasn't done their job. So they haven't scabbled the concrete surface. They haven't taken off all the bits of diesel and all the bits of rubber that's been on there for years and get back to a smooth concrete surface. And then you get this effect. You get the surface coming back off again. This was in Pretoria. This was under construction, the bridge. And what happened here, as you see, top right hand, a horse and trailer drove into the bridge. And the fire caused a lot of damage to that bridge. Unfortunately, the driver was killed. And I think a driver of the car on the top left-hand side was also killed. So it's a very tragic accident. And we then had to come along and had to clean the bottom right-hand side. You can see it's black. The whole bridge is blackened. We had to come along and clean the whole bridge off. And because of slight flaking of the concrete, we had to put an epoxy surface on the bottom of that bridge. That was part of the claim. That claim was paid. But that is a fairly straightforward CAR claim. There's damage to the works. There's no argument what's caused the damage. There's no design defect. That would be a straight works claim. This was an airport, and the airport was virtually complete. The whole roof was on. They were ready to fit out the airport. A windstorm came along and stripped all the roofing off the airport. We don't like that particular type of roofing. I don't think the next one shows you. No, we don't like that particular type of roofing. But anyway, the claim was paid. It was picked up under the works policy. It was not a design issue. It was a windstorm, exceeded the design. I think design was 1 in 30. It well exceeded design of 1 in 30, and the insurers paid under works policy. That's a fairly straightforward claim. This one here was a more difficult claim. This was, they were extending an existing shopping center. So if you look at the top left corner, the building which is badly damaged is the extension, and the existing shopping center is behind. And what happened here is as you see, the fire caught hold and burnt out the new building under construction. It also caused quite extensive damage to the existing building. So then you had a liability claim from the existing building, and you had a works claim from this building here. But again, these kind of claims are not too complicated. You've got a works, you've got a third-party claim coming against you. As long as you have adequate cover, something like this really should not be a problem. And that one, in fact, that one was paid out. It's more a problem clearing up rather than actually doing the claim. This was quite a complicated claim. This is in Australia. This was they were building an island to put a plant on the island. And they bought the plant already. It was a steel plant. They bought it from Germany. They loaded it onto ships and brought it out to Australia to put on this island. But there was a very bad communication between the contractors building the island and the guys who were bringing over the plant. So what happened here, the plant arrived, but the island wasn't finished. So those ships had to sit at anchor for a long time while they finished the island. And there was a lot of dispute on this particular. Every policy was triggered. The PI, the works policy, the liability policies, it was all triggered on this one. We got involved. We did all our kind of investigation, and then we advised insurers to walk away from it. This was a contractual dispute. It wasn't an insurance claim. And in fact, we did walk away from that one.
Martin, I see that we are at 11.
Oh, I'm not halfway through yet. All right. Okay, everyone's got to go and do some work, I suppose. All right.
But we'll schedule another one because I think we need to see the second half of this.
Well, I hope everyone picked up something from that, and there wasn't many questions, but thank you for the questions that did come through. Very appreciated.
Thank you. We have a lot of questions, but we'll get the questions and we'll respond to them separately. And also, everybody on the call, we have a very interesting one with Martin Vass on tailing dams at the end of the month on the 28th. So please join us for that. That's going to be a showstopper, Martin.
Well, thank you, Connie. Thank you for organising, and thank you for everyone for listening. I hope no one fell asleep and you enjoyed what I showed you.